Okay, welcome to Lesson 5. We're going to look at operations on fractions, and this is a long lesson. We've got 40 problems, and I'm going to work through each problem slowly and carefully. So if there's one or two, these are in your workbook. I will put a link to the workbook down below. So if you're just having problems with one or two, you can skip through and get to the one that you want to see. They'll be in order, okay? So we're going to start with fractions, and there are some tips up here to refresh your memory. When you add and subtract, you have to have common denominators. When you multiply, you just multiply straight across the top and straight across the bottom. When you divide fractions, that's when you do keep, change, flip. You keep the first one like it is, you change division to multiplication, and then you flip that other fraction, okay? Also, mixed numbers, it's easier. It's not necessary. There are some people that can mentally deal with it, but it's easier for me if you just change it to an improper fraction, work at it that way. And if you have a whole number, like we learned in the last lesson, you can always put that over 1. All right, so there's a blank out beside each problem, and I wanted you to put an A for addition, an S for subtraction, a D for division, and an M for multiplication. This helps you learn to analyze a problem before you just jump in there and start working it, okay? It really does make a difference. So when I look at this first one, I'm going to have an S. Now, how do you subtract? Well, to subtract, you must have common denominators. So what I'm going to do first here is I'm going to change both of these to an improper fraction. So 5 times 2 is 10, plus 3 is 13 fifths. Minus, and over here 7 times 1 is 7, plus 4 is 11. Now I need a common denominator. So you ask yourself, what's the smallest number that both of these can go into? You can always get that denominator by multiplying the two numbers together. It just won't always give you the smallest number, but you can reduce it later on. So if I look at these, and yes, 35 is going to be my new numerator. So I'm going to convert both of these. So what did you multiply 5 by to get 35? Well, you multiplied by 7. So you have to multiply the 13 by 7. So that's going to be 1. 7 times 3 is 21. Carry my 2. So that's 91. Right here, what did you multiply 7 by to get 35? By 5. So you got to multiply 11 by 5. So that's 55. Now that your numerators match, your answer is going to have that denominator. The denominators match, so your new denominator is going to be that same number. I just need to figure out what is 91 minus 55. So I would cancel. That's going to be 6, 36 over 35. Now, this is still improper, but it is lowest terms. Can you leave it that way? That all depends on what you're asked. As an algebra teacher, upper level algebra, I ask my students to leave it improper, because if we're going to work with it, that's easier. You see, the first thing we had to do on this problem was change it to improper. So when you continue to work with the number, it's easier if you just leave it improper, but it does have to be lowest terms. So is there a number that will go into 35 and 36? No. So this is a perfectly correct answer, but if your problem says change all mixed numbers or change all improper fractions to mixed number, you would want to write this as, how many times will 35 go into 36? 1 time. And when you subtract that 35, what do you have? 1 left over. So either one of these is the correct answer. It just depends on what your teacher or your problem asks you for. All right, let's move on. Okay, here's number 2, and this is a division problem. So out here in my blank, I'm going to put a D. That gets my head in the mode. What was my tip for division? Keep, change, flip. That's how you divide fractions. So, and that's something you just have to memorize. You know, that's a fact. That's how you do it. And there's a longer way you can do it without memorizing, but you know, use those tips to save yourself time. Just get it in your head. Fraction division, keep, change, flip. So we're going to keep 1/3 just like it is. we're going to change the division to multiplication, and then we're going to flip this. All right, we're going to multiply straight across the top. That gives us 3, and straight across the bottom gives us 6. Now, is this lowest terms? No. What will go into both of these? 3 will. So if I divide both of these by 3, I'm going to get 1/2 as my answer. Now, I know a lot of you are saying, hey, I know a shorter way. And yeah, I'm going to show you that too. Anytime you have the same number in your denominator and your numerator, even though these are crossways, they actually divide out at this point. What is 3 divided by 3? 1. And what's 1 times anything? That number. So you could have reduced that down at this point, and those give you 1 and 1, then multiply across the top, across the bottom, and you still get the 1/2. So whichever way you want to go about it. Okay, number 3. First, we need to fill in our blank. This is a subtraction problem. So that gets my analysis going. I know that for subtraction, I have to have a common denominator. All right, I see that I don't have mixed numbers, so I'm good to go. What I want to know is, what's a number that 12 and 8 both go into? So I always start with my largest number and start working my way up. What are multiples of 12? Well, there's 12. 8 won't go into 12. But 12 times 2 is 24, and both of these will go into 24. So could you just multiply 8 times 12 and use that number? Yeah, but it's going to be a big number, and you're going to have to reduce. So, you know. All right, now, what did you multiply 12 by to get your new denominator? By 2. So you got to multiply the top by 2. So that's 22. What did you multiply 8 by to get your new denominator? You multiplied 8 by 3, so you got to multiply the top by 3, so that gives you 9. All right, 22 minus 9 is 13 over 24. Now, will that reduce down? No, there's not a number that will go into 13 and 24, okay? Okay, for number 4, we see this is addition. Then analysis tells us when you add, you have to have common denominators. I see that they're both fractions. They're not mixed numbers, so I don't have to convert that. All right, what number will 8 and 5 both go into? I'm going to go with 40 here. All right, because 8 times 5 is 40, but I'm pretty sure there's nothing in between 8 and 40 that 5 will go into. All right, what did you multiply your old denominator by to get this new one? Well, you multiplied it by 8, so you got to multiply the top by 8, so that's 24. Then what did you multiply this old denominator by to get the new one? Well, that was by 5, so you got to multiply the top by 5. Okay, now that you're adding, that's going to be 29. And when you add, remember your denominators don't change, because that just tells you the size of the piece. This tells you how many of those pieces you have. So your size doesn't change, but the number of pieces you have does. So 29 over 40. Okay, for number 5, we do have addition. So what I'm going to do first is I am going to convert this to an improper fraction. So my first step, I'm not going to change 5/8, but I'm going to multiply. 7 times 2 is 14. Plus 1 is 15 sevenths. All right. Now, since I'm adding, I do need common denominators. Let's just multiply 7 times 8 and get 56 and go with it. What did you multiply the 8 by to get the new denominator? Well, you multiplied it by 7, so you got to multiply the top by 7, so that gives you 35. What did you multiply 7 by to get 56? Well, you multiplied it by 8, so you got to multiply the top by 8, and I'm going to have to do that out. 8, 9, 10, 11, 12, that's 120. All right, so now let's add. 35 plus 120 is 155, okay? Is there a number that will go into both of these? Well, they're not even, so that won't go. 5 won't go. Let's see, 5 plus 6 is 11, so 3 won't go in. So no, this is lowest terms. It's not improper. So if you want to change it to a mixed number, you can say, how many times will 56 go into 155? And I'm thinking 3 times, but I'll just show you. Remember, we don't have a calculator for these. We are doing no calculator. So 3 times 6 is 18, and 15, 168. That tells me that 3 is going to be too much. So I'm just going to have to go with 2. Now what's 56 times 2? 112. So I'm going to subtract 112 from 155. And that's going to give me 43 over 56. So 2 and 43, 56 is our final answer. Okay, for number 6, we do have a subtraction problem. So what I want to do first is I want to change these to improper fractions. So I'm going to do 2 times 4 is 8, plus 1 is 9 halves, minus 3 times 2 is 6, plus 1 is 7 halves, thirds. Now we need common denominators. What's going to be common between 2 and 3? Naturally 6. Okay? What did you multiply 2 by to get the 6? Well, you multiplied it by 3, so you got to multiply the top by 3, so that's 27. Now what did you multiply 3 by to get 6? Well, that was by 2, so you multiply that times 2, and that's 14. Now, remember, when you subtract, your denominator is not going to change. Your numerator, what's 27 minus 14? If you have to do it out, that's going to be 13 over 6. Now, can you leave it that way? Yes. Or you can change it to a mixed number. How many times will 6 go into 13? 2 times. 6 times 2 is 12, so when you subtract these out, that leaves you 1/6. Okay, let's look at number 7. That looks scary, doesn't it? In algebra, we actually call this a complex fraction, when it's a fraction over a fraction. But a fraction bar is just division. So we're going to put division here. Now, how do you divide fractions? You keep, change, flip. So I'm going to keep 2/5 as it is. I'm going to change this division bar to be multiplication, and then I'm going to flip this upside down. Okay. Now, if you remember, we looked at 1 and we said when you have a multiplication problem, anything that matches top and bottom you can cancel out. So that's what I did. And what it does is it leaves you with 1. So when you multiply all the way across the top, you get 2. When you multiply all the way across the bottom, you get 1. And any number over itself is just that number. Okay, number 8 is a multiplication problem. And when we multiply, we just go all the way across the top and all the way across the bottom. So 2 times 3 is 6. 7 times 7 is 49. So is there any way you can reduce that down? No, there's nothing that will go into 6 and 49. So that's your final answer. Okay, for number 9, we have addition. So you're going to put an A in the blank, and then your brain is going to say, okay, for addition, I have to have a common denominator. Now when you look at 10 and 5, what's the smallest number that both of these will go into? Well, 10. So I won't even have to change the first fraction. You can ask yourself, what did you multiply 10 by to get 10? Well, times 1. So 7 times 1 is 7. That didn't change. All right, now what about 5? What did you multiply 5 by to get the new one? You multiplied it by 2. So you got to multiply the top by 2. So now you have 2. Now, remember, when you're adding, your denominators don't change, and you add the numerators. So 7 plus 2 is 9 over 10. Okay, number 10 is multiplication. So the first thing you want to do when you're ready to multiply is change this to an improper fraction. 9 times 4 is 36, plus 1 is 37 over 9 times, and 3/8 is going to stay the same. Okay, now you can multiply straight across, or we can use that technique of canceling out to kind of help ourselves, because this is fixing to get kind of large, but that's fine. You could multiply and then reduce, but anytime you see a number on the bottom that will reduce with a number on the top. I've got 9 and 3. What number goes into both of those? 3 will. So if I divide this by 3 and I divide this by 3, what happens? Well, this makes 1 and this makes 3. Okay? What you're doing is you could multiply and then reduce. We're going to reduce first and then multiply. So now 37 times 1 is 37 and 3 times 8 is 24. It is lowest terms now, but it is still improper. So if you want to change it to a mixed number, how many times will 24 go into 37? 1 time. And then 37 minus 24 is 13. So you got 13 24ths. Okay, we have number 11, 1/4 times 3/4. When you have two sets of parentheses, that indicates multiplication. So this is going to be an M problem. And when you have multiplication, if you can reduce, you can, or if you want to. This one, nothing reduces. So we're just going to multiply straight across the top, which is 3. Straight across the bottom is 16. That won't reduce, so that's your final answer. Okay, number 12, 5/6 minus 2/5. This is subtraction. So the first thing I'm going to need to do is get a common denominator. And you're just going to wind up multiplying the two of them together. So it's going to be 2 new fractions, both with a denominator of 30. So you ask yourself, what did you multiply 6 by to get 30? Well, you multiplied it by 5. So you got to do the same thing to the top. And that gives you 25. Would you multiply 5 by to get 30? Well, times 6. So you got to multiply the top times 6. So you get 12. Now when you subtract, remember your denominator is not going to change. So we're going to do 25 minus 12, which is 13. Is there any way to reduce that? No. Okay, for number 13, we have another one of those complex fractions. So before I can flip it, well, let me write division here so I can keep that in my head. Now, how do you divide? You keep, change, flip. Well, you can't flip a mixed number. So your first step here is going to be to convert both of these to improper fractions. 9 times 4 is 36 plus 1 is 37 over 9 over 8 times 1 is 8, 9, 10, 11 over 8. Now when we keep 37 over 9, we multiply and then we're going to flip, so that's going to be 8 over 11. Now, what are we going to have? I am a horrible mental math multiplier, so I'm going to do this out. 8 times 7 is 56, carry my 5. 24 plus 5 is 29, so that's 296 over 9 times 11 is 99. Now I go through my little reduction things. There's not a number that will go into both of these. The little trick I told you about adding all your numbers up, if you add 6 plus 9 plus 2, you get 17, and 3 won't go into that. So 9 won't go into it, because that was my thing. I thought maybe 9 would go into both of those, but it won't. So our only option here is, if we don't like the way that it looks, we can change it to a mixed number. So how many times will 99 go into 296? Well, it'll go in there 2 times. 99 times 2 is 18, 198. And 296 minus 198 is 8. That's going to be, and then you'll have 98 left over 99. Okay, number 14 is an addition problem. And when you add, you need common denominators. So that's my first task. What is a number, the smallest number, hopefully, that 4 and 3 will go into? Well, that's going to be 12. Now let's manipulate both fractions. What did you multiply 4 by to get your new denominator? By 3. So you got to multiply this by 3. So that gives you 3. Now, what did you multiply 3 by to get that new denominator? You multiplied it by 4. So you got to multiply the numerator by 4 and get 8. Then we're just going to add straight across the top, get 11. Now remember, you don't add your denominators, they stay the same. So your correct answer is 11/12. Okay, for number 15, we do have addition, and we have mixed numbers, so my first step is going to be to convert these to improper fractions. 6 times 1 is 6, plus 1 is 7, so that converts to 7/6. 8 times 2 is 16, 17, 18, 19, 20, 21 over 8. So now I need a common denominator. And I'm going to take 8. Let's run through the multiples. 16, 8 times 3 is 24. And there's a bingo. 6 will also go into 24. So let's go there. You could multiply 6 times 8, get 48, and go with it, but then you're going to have to reduce. So either way, it's up to you. Now you ask yourself, 6 times what is 24? Well, 6 times 4. So you got to multiply 7 times 4. That's 28. All right, 8 times what is 24? 8 times 3. So you got to multiply this times 3. So that's 63. Okay, now your denominator is not going to change. When we add 28 plus 63, 8, 9, 10, 11, carry your 1, 6, 7, 8, 9. That's going to be 91 over 24. And I'm thinking there's not anything I can reduce that with, but if you want to change that to a mixed number, how many times will 24 go into 91? Let me see if it'll go 3 times. That would be 12, 6, 72. It will. So I can rewrite this as 3, and then 91 minus that 72 is going to be 19 over 24. Okay, number 16 is addition. And I need a common denominator. So between 3 and 7, pretty good bet that that's going to be 21. All right. Now, what'd you multiply 7 by to get the new denominator? You multiplied it by 3, so you got to multiply the top by 3, so that's 15. What did you multiply this denominator by to get the new one? By 7, so you got to multiply that by 7. Now, remember, denominator's not going to change. So what is 15 plus 7? 8, 9, 10, 11, 12, 22 over 21, which is lowest terms, but it is improper. So if you want to change it to a mixed number, 21 will go into 22 one time with 1 left over 21. Okay, number 17 is multiplication. Now, how do you multiply fractions? Numerators and denominators. Well, 9 doesn't have a denominator, so what you can do is we're going to put 9 over 1, all right? And then we're going to multiply straight across the top and get 9, straight across the bottom get 2. We can leave it that way, or it is improper, we can change it to a mixed number. So how many times will 2 go into 9? Well, 4 times. And then we're going to subtract 2 times 4 from 9 and get 1/2. Okay, for number 18, we do have multiplication. And when you multiply, you just go straight across the top, straight across the bottom, and reduce if possible. And there's no possible way. So that was just some practice in multiplying. Okay, number 19 is a division problem. So the first thing I'm going to do is change these to improper fractions. 7 times 1 is 7, plus 2 is 9 sevenths. I'm going to leave it division for now. 2 times 4 is 8, plus 1 is 9 halves. Okay, now it is time to keep, change the division to multiplication, and flip. And then we see our friend of the matching numbers. When you multiply, now you have to be specific. When you are multiplying fractions, any numbers in the numerator that match numbers in the denominator can be reduced. You're just dividing them out, okay? So you get 1 and 1. Then you can multiply straight across the top to get 2, straight across the bottom to get 7, and that is not improper, and it is lowest term, so you're good to go. Okay, let's look at number 21. This is an addition problem. So I have mixed numbers. The first thing I'm going to do is change these to improper fractions. 3 times 1 is 3, plus 1 is 4 thirds, and 2 times 1 is 2, plus 1 is 3 halves. What's going to be our common denominator between 2 and 3? 6. That was an easy one. All right, what did you multiply 3 by to get your new denominator? You multiplied it times 2, so you got to multiply the numerator times 2 and get 8. All right, what did you multiply this denominator by to get the new one? You multiplied times 3, So you got to multiply this times 3, and you get 9. All right, 8 plus 9 is 17/6, which is lowest terms, but if you want to change it to a mixed number, how many times will 6 go into 17? 2 times. 2 times 6 is 12, so then you subtract that 12 from 17, and you get 5/6. Okay, number 22 is a multiplication problem, so it gets an M in the blank. And I'm going to change both of these to improper fractions. 6 times 5 is 30, plus 1 is 31/6, times 3 times 2 is 6, plus 1 is 7/3. All right, I don't see anything that I could go ahead and cancel down, so I'm just going to multiply. 7 times 31, well, 7 times 1 is 7. So it's going to be 217/18, and there is not a number that will reduce those down. If I want to change it to a mixed number, how many times will 18 go into 217? It will go 12 times, and 12 times 18 is 216. So then when you subtract, that's going to leave you 12 and 1/18, 1/18, but you could leave it like this. Okay, number 23 is a division problem. And how do you divide? Keep, change, flip. They're both already in fraction form, so I don't have to convert. I'm going to keep 6/5 like it is. I'm going to change division to multiplication, and then I'm going to flip 3/1. All right? Then multiplying, you just do straight across the top. 6 times 3 is 18. Straight across the bottom, that's 5. This is lowest terms. Nothing will go into both of them. But we can make it into a mixed number. 5 will go into 18 3 times. 3 times 5 is 15. So then you subtract that from your numerator. So you have 3 3/5. Okay, number 24 is multiplication. And to multiply fractions, you multiply straight across the top, straight across the bottom. So I'm going to change this one to an improper fraction, and then I'm going to put 3/1 so that it's in fraction form. 7 times 2 is 14, plus 1 is 15/7. And I'm going to multiply that times 3/1. All right, 3 times 15 is 45/7. Now, it won't reduce, but I could say, change this to a mixed number. 7 will go into 45 6 times. So that's going to be 6. Now what is 6 times 7? It's 42. So I got to subtract that from the numerator. 45 minus 42 is 3/7. Okay, number 25 is a subtraction problem. And to subtract fractions, you do need a common denominator. So let me come under here. Pick your largest number and start running through the multiples. What are the multiples of 6? Well, you've got 6, you've got 12, and you can stop right there. Because you're looking for a multiple of 6 that 4 will also go into, and 12 works. Now, what did you multiply 4 by to get 12? You multiplied it by 3, so you got to multiply the top by 3. That gives you 9. Now, what did you multiply 6 by to get 12? Well, you multiplied it times 2, so you got to multiply the top times 2. Now that your denominators match, remember that denominators do not change in addition and subtraction. They stay the same. Subtract your top ones, you get 7/12. That won't reduce, and it's not improper, so we're good. Okay, number 26, 5 1/2 minus 1/3. So this is a subtraction problem. And I'm going to change my mixed number to improper fraction. 2 times 5 is 10. 10 plus 1 is 11/2 minus 1/3. All right, now I need common denominators. Between 2 and 3, obviously that's 6. So let's convert. What did you multiply 2 by to get your new denominator? Well, you multiplied it times 3. So you got to multiply that times 3. So now we have 33. All right, what did you multiply this by to get the new denominator? You multiplied it times 2. So you got to multiply the top times 2. So that gives you 2. Now you have 31/6, 33 minus 2. Okay, it is lowest terms, but if you want to change it to a mixed number, How many times will 6 go into 31? Well, it'll go 5 times without going over. So 6 times 5 is 30. I'm going to subtract that from the numerator, and I have 1 left over 6. Okay, number 27, 4 1/8 plus 2 1/6. So we're adding mixed numbers. What I like to do, let's put an A here because we are adding. When I'm adding, I like to just go ahead and convert to improper fractions. A lot of people don't. They'll add the whole numbers and then add the fractions. That's perfectly fine as well. I'm just showing you how I like to do it. So when you convert, 8 times 4 is 32 plus 1 is 33 over 8 plus 6 times 2 is 12, so that's 13 over 6. Now, I need a common denominator between 6 and 8. Go to your, yes, you could just multiply 6 times 8 and go that way, but that might be too big. So go to your largest number and let's start writing down the multiples. 8 times 2 is 16, 8 times 3 is 24. And you see right there, 6 will also go into 24. So you've identified a number that is less than 48. That means you won't have to reduce down as much. So we're going to change both of these to something over 24. All right, what did you multiply 8 by to get 24? Well, you multiplied it by 3. So you got to multiply 33 by 3. So that's 99. What did you multiply 6 by to get 24? Well, you multiplied it by 4. So you got to multiply 13 by 4. So that's going to be 4 times 3 is 12, 52. All right, now to add, since your denominators match, we're going to add 99 and 52. That's 11, so that's 15. So we get 151 over 24, okay? This is a perfectly good answer, but can we reduce it down? And yes, well, you can't reduce it down, but you can change it to a mixed number. So how many times will 24 go into 151? I'm thinking about 6. So how do you find it out? Well, multiply 24 times 6. 6 times 4 is 24. Carry your 2. 12, 13, 14. 144, that is less than 151, but it's not 24 less. So now 151 minus that 144 is going to be 7. So you have 7 24ths left over. And remember, I know this seems like overkill, but there are embedded skills in all these problems, and you practicing these is going to make it so much easier. When you get to the algebra point, yes, you get a calculator to do all this numerical stuff, but you're still having to use the same techniques. So just bear with me, work your way through it without a calculator, and I promise it will all be worthwhile. Okay, let's look at number 28. We do have a division problem, so we're going to put a D. How do you divide fractions? You keep, change, flip. So we're going to keep 3/16 like it is. We're going to change division to multiplication, and then we're going to flip our last number. All right, multiplying straight across the top gives me 9. Straight across the bottom is 16. Nothing will reduce, so there's your final answer. Okay, for number 29, once again we have division. We do have mixed numbers. So I'm going to convert to improper fractions, and then I will keep, change, flip. And I'll go ahead and put a D here. All right, 6 times 7 is 42, plus 6 more, that's going to be 48 over 7. And I can go ahead and change this to times. All right, 3 times 3 is 9, plus 1 is 10/3. But since I'm going to flip it here, that's going to be 3 over 10. All right, so let's do our trick, you know, to keep the number small. I see 48 and 10 on opposite sides of the fraction bar, so I can reduce that now if I want to. What is one number that will go into both of these? How about 2? So if I divide 10 by 2, I get 5. 48 divided by 2 is 24. And that just reduces it at this point. You could multiply straight across and then reduce at the end. You'll still get the same answer. So now 24 times 3 is, let's see, 3 times 4 is 12. 6, 72 over 35. Now, is there a number that will go into 72 and 35? No, but I can change it to a mixed number. How many times will 35 go into 72? 2 times. Now, when you take that out, what's 2 times 35? That's 70. So you've already removed 70 of your 72 pieces. What do you have left? 2 35ths. So either one of these two answers is correct. Okay, for number 30, we are multiplying. So that means you can multiply straight across the top and straight across the bottom. And then you would have to reduce. 3 will go into both of these, so you get 2 fifths. Or, yes, you're probably saying, why didn't you just cancel? You can do that as well. I could have canceled these 2 3's, multiplied straight across the top, and gotten 2 fifths and not had to reduce. Okay, number 31 is addition. I already have just fractions. There's no mixed numbers that I have to convert. So what I'm looking for is a least common denominator. So obviously, you know, I'm going to have to go all the way on this one. I'm going to need 77. Okay, so what did you multiply 7 by to get 77? Well, you multiplied it by 11. So you got to multiply the top by 11. That gives you 22. What did you multiply this by? Well, you multiplied it by 7. So you got to multiply the top by 7. You get 21. Now, remember, when you add, your denominator doesn't change because that just tells you the size of the piece. Now, if you have 22 plus 21, that's going to give you 43. That won't reduce down, so there's your final answer. Okay, number 32 is a subtraction problem. And I'll show you what I mean on this one. This will be a good example. I'll show you how you can do this without converting it to an improper fraction first. A lot of people prefer this way. What you do is you make it into 2 separate problems and you say, all right, first, 2 minus 1 is 1. You're still going to have to do 5/6 minus 4/15. So let's come over here on like some scratch paper and do that. What would be a common denominator between 6 and 15? Go to your largest number and start looking at the multiples. All right, you've got 15. What's 15 times 2? 30. And bingo, 6 will go into 30. So I can just choose 30. Now, what'd you multiply 6 by to get your new denominator? You multiplied it by 5, so you got to multiply the top by 5. So that gives you 25. Now, what did you multiply 15 by to get the new one? Times 2. So you got to multiply the numerator times 2. That's 8. Okay, your denominators match now. So what's 25 minus 8? 17. And that's going to be your fraction part of it. So either way you want to go, you know, change it to improper fraction and then subtract the whole thing. And then you would probably have to convert it back to a mixed number, or you can start, you know, just do the numbers. Now, if you had the improper fraction, that would be 30. You would have gotten 47 over 30. So either one, either way. Okay, number 33 is multiplication. Now, multiplication, you do need to convert these to mixed numbers. You can't just say 1 times 2 and 1/2 times 1/5. It doesn't work that way for multiplication. But what we can do is change it to improper fraction. 2 times 1 is 2, plus 1 is 3 halves, times 5 times 2 is 10, plus 1 is 11 fifths. Now, there's no reducing you can do at this point, but 3 times 11 is 33, and 2 times 5 is 10. This is lowest terms, but it is improper. So if you're asked to change it to a mixed number, how many times will 10 go into 33? 3 times. So that took away 30 of the pieces. How many are left? 3, and it's over 10. Okay, number 34 is a subtraction problem, and using that split method would be really cool on this one. Since it's subtraction, you can just do the whole numbers and the fractions. So I can just say 6 minus 2 and 1/3 minus 1/3. Well, 1/3 minus 1/3 is 0, and what you're doing is you're adding here. 6 plus 2 is 4, so your total answer is actually 4, okay? If you wanted to change it to improper fractions, you know, just in case this is what you did when you worked it, let me show you how that way would be. 6 times 3 is 18, so that's 19 thirds minus 7 thirds. What's 19 minus 7? 12 thirds. And what's 12 divided by 3? 4. So you get the same answer either way. Okay, number 35 is multiplication. So let's go ahead and change these to improper fractions and then multiply across the top and across the bottom. 5 times 6 is 30, plus 4 is 34 over 5, times 3 times 1 is 3, 4, 5 thirds. And you see it, these two can cancel out. So what you get is 34 over 3. Now, this is lowest terms, but it is improper, so if you want to change it to a mixed number, how many times will 3 go into 34? Well, it'll go 11 times. All right, once I take out 11 of those 3's, that's 33. So I'm going to subtract that, and I'll have 1/3 left. Okay, let's have a look at this one. This is a division problem. So when we get ready to divide, we're going to keep, change, flip, but in order to flip, we need this mixed number in improper fraction form. So let's do that first. 3 times 2 is 6. 6 plus 4 is 10. So improper form of that is 10 thirds. All right, I'm going to go ahead and change this to times, and then we'll flip it. 2 times 1 is 2, plus 1 is 3. So this is actually 3 halves, and when I flip it, it's going to be 2 thirds. All right, 10 times 2 is 20, over 3 times 3 is 9. It won't reduce down, but I can change it to a mixed number. How many times will 9 go into 20? 2 times. 9 times 2 is 18, so I'm going to subtract that 18. So you could either put 20 over 9 or 2 and 2/9. Okay, number 37 is a subtraction problem, and we're already in fraction form, so let's get a greatest common factor. Now between 6 and 7, experience tells me that I'm just going to have to go ahead with 42, 6 times 7. All right, what did you multiply 7 by to get the new denominator? You multiplied it by 6, so you got to multiply the top by 6, so that gives you 36. What did you multiply this denominator by to get the new one? Well, you multiplied it by 7, so you got to multiply the top by 7, so there you go. Now when you get your answer, remember the denominator stays the same. 36 minus 7 is 29, and that's going to be your final answer. It won't reduce down. Okay, number 38 is division, and I want to keep, change, flip. So, watch this. First, let's just get this changed to an improper fraction. 2 times 2 is 4, plus 1 is 5 halves, times. All right, how am I going to flip that? Well, if you'll remember, you know, any whole number over 1, that's how you make it into a fraction form. So what happens when you flip it? Becomes 1/3. Now multiply straight across the top, straight across the bottom, the one and only final answer. Okay, for number 39, we do have addition. So, yeah, let's try the split method. What if I do 1 plus 4, and then to that I add 3/12 plus 1/8? That would be cool, huh? Because that's going to be 5. All right, now, what's going to be a common denominator? Let me come over here to do these. What's going to be a common denominator between 12 and 8? Go to your largest number and look at the factors. What are the multiples? What are the multiples of 12? You've got 12. Your next one is 24, and 8 will also go into 24. Lesson 1, knowing your multiplication facts is going to help you here. All right, so our new denominator is going to be 24. What did you multiply this old denominator by to get 24? Well, you multiplied it by 2, so you got to multiply the top by 2. That gives you 6. Now, what did you multiply this denominator by to get the new one? Well, you multiplied it by 3, multiply the top by 3, and now you are ready to add. What's 6 plus 3? 9 over 24. So right now we have 5 and 9/24. Now will anything go into 9 and 24? How about 3? So you can reduce this down by dividing both of those by 3, and that's going to get you 5 and 3/8. Okay, number 40 is a subtraction problem, and we need a least common denominator here, which is actually going to be 8. Both of these will go into 8, so your first fraction is not going to change. Now, what did you multiply 2 by to get the 8? Well, you multiplied it by 4, so you're going to need a 4. And then remember, your denominator will not change. 5 minus 4 is 1. That is the one and only answer. So you're good to go. That's the end of lesson 5, and that was intense. I know. That's a lot of problems, and there was a lot of mental math that you've usually done with a calculator. So that built a lot of character as far as math goes if you did the whole thing without a calculator, which I hope you did. You can check your work with a calculator, but right now, you know, we are practicing these basic skills. And it's like I told you, when we get up into the algebra part, you're going to need to use these techniques with variables, and you can't do that with a calculator. So you need to know how all this works, okay? I promise it will be worth it if you just hang with me. I'll see you back here for lesson 6.